What's up everyone, welcome back, Patrick here, and in this next video we're going to take these two lines over here and figure out whether they're perpendicular, parallel, or neither. So notice in this case we're dealing with a lot of decimals here, and personally if I get something like this, what I like to do is put the line in y equals mx plus b form and then put both lines in this form and then just compare the slope. So if we do that here, notice we would have 14y equals negative 11.2x plus 2.8. We're going to isolate for the y. So we brought this over to the right side. Then we could divide everything by 14. So notice here, these cancel out. So we'd end up with y equals, this would end up being negative 0.8x plus 0.2, like that, right? So this line and this line, they're the exact same thing. It's just now we have it in this y equals mx plus b form. So that's one line. And then over here, if we do the same thing, because this is a negative, I'm going to bring it over to the right side. I usually like to make sure that the coefficient is positive that I'm going to be dividing by. So the 1.5 I brought over, and then divide everything by 3, and we would end up with 1.25x minus, this would just be 0.5, and then we have y. And then you could just write it as y equals 1.25x minus 0.5, like that. All right, so this here is the other line in y equals mx plus b form. And so from here, you can compare the slopes. What are the slopes? Well, the slope here is negative 0.8, and then the slope over here is 1.25. So we definitely know they're not going to be parallel. If they were parallel, then both of these slopes would be the same. The question is, are they going to be perpendicular? Now, if you remember, perpendicular slope, so let's say we have a slope of a over b as a fraction. Well, a perpendicular slope is just going to be the negative reciprocal of that. So we would flip this and then put a negative there, just change the sign. Or if this was negative, then this would end up being positive. The sign is always going to change. But notice here, these aren't in fraction form. We can convert them to fraction form, but if you want a quicker way to check, another way to kind of show this relation is basically negative 1 divided by a slope would give you a perpendicular slope. So notice how it would work here if we took negative 1 and divided it by a over b. That would be like negative 1 over 1 divided by a over b, which would be like negative 1 over 1 times b over a, which would give us negative b over a. All right, so that's another way to relate a slope and a perpendicular slope. So what we could do to check if they're going to be perpendicular, these two slopes, is we could take negative 1 divided by this, and negative 1 divided by negative 0.8, the negatives would cancel out, and this would actually give you 1.25. And so the slopes are perpendicular. If you went the other way, if we took negative 1, divided it by that slope, this here would give you negative 0.8. So you could always use this if you run into equations of lines that have a more complex format for the slope, or a decimal format for the slope. You could always check it with this over here. And then if this holds, then they're going to be perpendicular. So that's the answer to this question. These lines here, they are perpendicular. Another way we could have done this is maybe took the negative 0.8, converted it to a fraction. So this would be like negative 8 over 10, which would simplify to negative 4 over 5. Right? Negative 4 over 5, negative 0.8 is the same. Then 1.25, that would be like 125 over 100. which we could divide this by 25, divide this by 25, which would give us 5 over 4. And notice negative 4 over 5, 5 over 4, those are negative reciprocals of each other. So that's another way to go about it. Maybe this is a good way if you're not going to have a calculator on a test, but personally, this is what I use. So whichever way you do it, the answer to this question is that both of these lines are perpendicular.